All right. So today what we're going to talk about is I'm going to talk about linked list but using record data type. Linked list but using record data type. Okay. So now what you do is what you need to do is it's a very simple idea. Let's just look at this part right here. So at the end of the day, A, C, E, G. Okay. Later you see I'm going to add A, C, E, G. Then delete E, add I and K. So that means if let's just say I were to output for you, so let me run this. Let me don't put it here. So let's put A, C, E, G. Let me add node first. Yeah, A to C to E to G. So you see, this is what we call a linked list. This is what we call a linked list. Okay. Okay. Now, so the way to use it this time, instead of using a 2D array, where the pointer is pointing towards an index. Okay. For this particular one, what we'll be doing is we'll be using a record data type. Now, you'll notice that the record data type in Python is using class. Yes. Why? I want to imagine what's the difference between record data type and classes, object-oriented programming. Record data type is a collection of different data types. Okay. Class is a collection of the attributes as well as method, its behavior. So if you strip away the behavior, what you have is actually just what you can call it a record data type. That is how they implement record data type in Python. Okay. So I'm going to start simple. The data, because it's all in alphabet, so the data I'll just put in as in an empty string. Okay, so this one I'll put as empty string. Now, for node, right, I will put in none because I won't put an integer because actually the pointer is pointing towards the memory address of the next class. The actual memory location of the next record data type. So this is why I put none object. It really means nothing inside there. Okay. So first we start with A because we haven't added anything yet. So the start node is none. No object. Now none. Okay. Now take note now, all these are still currently function. I haven't added. So now I'm going to add A, C, E, G. Okay. Add A, C, E, G. Oh, let me put here. Start node dot data. Okay. Maybe this one get smaller. Okay, now it looks nicer. So this is start node data. This is new node pointer. Okay. Okay. So let us begin. Let us begin. So item we're gonna first do is add A. Let us see what happens at add A. So when you begin the loop, right, please remember the currently data, the thing is none, really none. So really none. Okay. Previous node none. So that means inside there really also none. Nothing inside there. Okay. New node. Okay. So the pointer there is none. Okay, sorry. I haven't entered the loop yet. I haven't entered the while loop yet. Okay. So right now I'm here. New node. So new node pointer is created none, and then this one becomes empty string. Okay. So right now I'm here already. New node.data equals item. So because I added A, right? So let me insert. So now here becomes A. Okay. All right. Here becomes A. Current node equals to start node. So now So current node data, none. Previous node data, also none. Only the new node data, although the pointer is none, we managed to put in A inside the new node. Okay. If start node is none, okay, if start node is none, start node equals new node. Okay. So right now, start node is indeed none. Start node equals new node. So that means on the new node data, or this one will be A. And then what will be the start node pointer? It points towards none. Current node leh, while current node is not none. So current node is none, doesn't enter there. So, actually, sorry, because of the else, or because of if, right, enter this, right, skip the whole thing. So we have established A already. We have established A as our first node, and that will be the start node. Okay. Okay. So I'm going to add A. I'm going to let me wrap this off first. I'm going to add A, C, E, G. I'm going to add A, C, E, G. Okay. So now we already established that the thing is A already. So let me add a few more. Okay. Okay. Now we add C. So start node pointer is sorry. Hold on now. Freeze pane, freeze top row. Okay. Okay, good. So now what we are going to do is A. Okay, so now we're going to add item. We're going to add item C. Start node. So start node is A. Previous node equals none. Previous node equals none. Okay. Okay. Sorry, let me maybe make it clearer. I maybe put this as a line. Okay. Ticker. Sorry. Yeah. Yeah. Okay. So this is none. Okay. So this is A already added now. New node equals to node. Okay. New node equals to node. So I created this one and then none. Okay. New node dot data equals item. So now my here, right, I put C under the new node there. Under the new node there. Do take note, start node data is A. So A is your start node, previous node nothing yet. New node data I created already, and I put C inside as the data. If start node is not none, start node got data inside there is A so start node is available already. While current node, okay, current node equals to start node. So that means what's happening right here is current node right here will equals to A. Because current node equals to start node. So the A, right, from the start node, right, is become current node right there. If start node is none, start node got data while current node is not none, current node is not none. So enter already. So now we're entering into our first proper loop, first loop of the while loop. Previous node equals to current node. Previous node equals to current node. So previous node data now becomes A. Current node equals to current node pointer. Current node pointer points to where? Current node pointer points to none. Because after A, nothing already So current node data is none. The whole current node, there's no current node right there. So after the first loop, exited out already. Okay. Now, previous node data, previous node pointer points towards the new node. So that means the previous node pointer equals to new node. The new node is actually a box, an object. The memory location of that will be stored at the previous node pointer. The memory location of that will be stored at the previous node pointer. And that's how you get A linked to C. A link to C. That's why you see our previous node dot pointer equals to new node. The entire box of the new node, the memory location, will be stored at the previous node dot pointer. Where, please remember, the previous node pointer currently is none. But now the none is replaced with the memory location of C, the new node. Make sense or not? And then the new node pointer, none. So A point to C, C points towards nothing. Okay, yeah? Okay. Now let me do this. All right. So start node still A. Okay. Okay. Start node still A. Now we're entering E. Okay. Previous node equals none. Okay, none. New node is create a new node, empty, the pointer will be none. New node dot data item. So right now ACE, I put E inside the data for the new node. What's the pointer for the new node? None. Anything pointers towards E? Nothing. So I hope you guys can see, and then current node equals to start node. Okay, so here equals to A. So I want you to remember up until here is you are preparing it. What is happening right now for this previous steps here is that you are connecting, okay, the attaching the new node to the linked list. It is easy to create a new node and put in the data. So for example, you look right here, I've created the new node and I put it E as the data already. Very easy to do that. Always the more challenging part for linked list, right, is how do you point the linked list to the new node. Okay. 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 So now we are current node is not none. Current node is the A1 got the A1 so it's not none, no? Okay. Previous node equals to current node. So now what's going on right now? Now enter the loop, already enter the first loop, A. Okay. So now previous node dot data point is A. Current node equals to current node pointer. I want to ask one thing. A point towards where? A point towards C. So the current node data from A has been updated to C. Is current node empty? Current node is not empty. Still go through the loop. Now what happens? Previous node equals to current node. Previous node is A, points towards C is current node. Now we again update C. Okay. Previous node equals to current node. Okay. Current node equals to current node dot pointer. C point towards where? C point towards nowhere. Empty. So right now, current node point towards none. Okay. Previous node pointer point towards new node. Now the C where the pointer is empty. Now the E, the memory location of it, will be stored in the C pointer the C previous node dot pointer, that one will store E. So that means after A points to C, after C points to E, you have successfully updated the linked list. Now C points towards E. Okay. Okay. Okay, makes sense or not so far? Makes sense, hopefully this makes sense, Okay, we do one more time again. Now we're going to add in G. Okay, again, add item. Previous node equals none. Previous node equals none. Okay. Start node is A. Inside there got A. Okay. Sorry. Blur case me. New node is empty. We create an empty new node where the pointer is point towards none. And then we put in the item A, C, E, G. We haven't entered the loop, we're just starting only, we're just prepping up only. Okay, current node equals to start node. So right now, current node updated, start node, we start with A again. So the main idea behind it all, now we are going to go through the loop again, is that you are updating it from A, C, E. Now you want the E to point towards G. You want the E to point towards G. But we must always start from A because we do not know when the linked list will end. That's why we always start from A until reaches the end, and then we attach the G to it. Okay. Okay. So in this particular case, now we enter the loop 1, 2, 3. Okay, now let's enter the loop. Current node is A, it's not none. Previous node equals to current node. That means now the data is now under previous node already lah. Current node equals to current node dot pointer. A point towards C. So now current node dot data updated to the new node C. Is C empty? C is not empty. So again, go through the loop a second time. Previous node equals current node. That means current node updated call it previous node. So now previous node, call it C. C point towards E. That will become your new current node. Make sense or not? Current node dot equals to current node dot pointer. So A dot pointer points towards C. C becomes the new node. C dot pointer points towards E. E now becomes a new node. Becomes the current node. Sorry, becomes the current node. Again, still not empty. E. Okay. E. Before you attach G, E is pointing towards none. Exit the loop. Previous node dot pointer, which is referring to E, now points towards the new node, which is G. And that's how you add nodes using record data type. The reason it works beautifully, it is because the way it works is that Python is actually always by reference. So when we say new node attaches to a pointer, we're actually taking the memory location of that and putting that memory location into that pointer. Okay, all right. So now our next goal, right, is that what you want to do is I'm going to now delete E. So now I'm going to remove E. Now let's look at that. Okay. Yeah. Okay. Okay. Item delete is E. We want now to remove E. So remember our goal is A, C, E, G. This is the one that we want to remove. E is the one we want to remove. Okay. So how do we go about that? Okay. We need to remember whenever we want to go through this part, it's always traversing the linked list now. You always need to start with something first one. You always need to start with something one. Global start node is A. Okay. Previous node equals none. Okay, previous node equals none. And then start node equals A. Okay. So we have current node equals A, previous node equals none. Okay. If current node is not none, that means there's a linked list. Okay. If item delete equals current node dot data, start node equals to current node pointer. What does this mean? Okay. This one it actually means what if A is the item you want to delete? What if A is the item you want to delete? Then what happens is that for them it's very simple only. Start node equals to current node pointer. So that means current node dot pointer is pointing towards C, right? Update the start node to point towards C, done. C, E, G. No need to traverse the linked list because the first item to be deleted, if let's just say that your start node is the data to be deleted. So all you need to do is take the pointer for this pointer to C, that become your start node. Let C be your start node. That's what this means. So this one quite straightforward lah. Okay. Now, while current node is not none and item delete is not current node data. Okay. Okay, sorry. We want to remember now we want to delete E. We want to delete E. Please remember we're looking for E. Okay. So now current node is got item is A. Item delete is not E. A is not E. Okay. So let's look through it. 1. Previous node equals to current node. So previous node, right, is none, right? Now becomes A. The data is A. Current node equals to current node dot pointer. A point towards C. Okay. Is C E equals to E? C does not equal to E. Look through the loop again right here one more time. Previous node equals to current node. So now previous node now becomes C. Current node current node dot pointer assigned to current node. C point towards E. Okay. What's going on right now? Okay. Is E equals to E? Yes. Do not enter the loop anymore. Exit out of the loop already. Now we come here. Previous node pointer points towards current node pointer. Okay. This is your previous node. Okay. This is your current node. Okay, E is your current node. So what they are trying to say is that the C pointer, right, don't point towards E. Where is E pointing to? E is pointing towards G. The C pointer now point towards G. Because remember, initially it is A, okay, A, C, E, G. C point towards C, E points towards G. But what this does is that it's telling you the previous node, which is C, don't point towards E anymore. Point towards what E is pointing. E is pointing towards G. C now point towards G. Take the memory location of G. So C, skip E, straight away jump to G. And that's how you remove E from the linked list. So now C only sees G. That's how C now only sees G. Okay. Okay. So yeah, so this one is also the same idea. Again, the main goal behind it of this very long thing is again traversing the linked list. Previous node, new node, previous node, new node, until you find the item that you're looking for. That is how it works. With that being said, thank you.